Hello, 7th graders. Today you are going to be learning about the Pythagorean Theorem. So your target is I can use the Pythagorean Theorem to find the missing side of a right triangle and determine if a triangle is a right triangle given the three side lengths. You can kind of sum that up to you will be able to find, you will be able to use the Pythagorean Theorem, which you will learn what that is in a short minute here. If you're following along in your book, please look at page 162. So we're going to kind of make this into a little story almost. This little picture here shows squares, which makes sense because we see the symbol of a square or the power of 2. We're going to be talking about squares and triangles a little bit today. So this is Pythagoras. This is a man over 2,000 years ago. There was amazing discovery about triangles. So what they learned was that if a triangle has a right angle, 90 degrees, remember it's a right angle, and you usually see that denoted by this little box here, okay? So it has a right angle, and squares are made on each side of the three sides. Then the biggest square has the same exact area as the other two squares put together. That's what it means. So you take this triangle, make a square of this side length, a squared, this side length b squared. The sum of those two areas is side times side, so it makes sense. Area squared for a squared is the same as the longest side's area by itself. So that's a squared plus b squared equals c squared. This is called the Pythagoras Theorem, and it can be written in short, a squared plus b squared equals c squared. You'll get used to this a lot, you'll say it a lot, and you will plug into it a lot to find a, b, or c. The definition again, this is showing up a lot, so maybe it's important for you to write down, okay? And if I go through this too quickly, I might go back through and scroll just so you have that time, but luckily you can pause me if you need to. So the longest side of a triangle is called the hypotenuse. The shorter two sides are called legs, okay? So the legs right here, kind of what the triangle stands on. If you turn it either way, you usually place it on one of its straight edges. So A and B are its legs. C is the hypotenuse. The formal definition of this is in a right angled triangle, with a right angle there, the square of the hypotenuse, squaring that side length, is equal to the sum of the squares of the other two. Okay? Some things to know about the hypotenuse is that the hypotenuse is the side opposite of the right angle. So if your right angle is here, hypotenuse is over here. Okay? I could draw a couple different triangles here. It's the same direction. So if I swivel this one around, my right triangle is still here, so my hypotenuse would now be this side. So your triangle can be rotated, but the hypotenuse is always opposite of the right angle. Also, your hypotenuse is the longest side of the triangle. So later we'll see that when we were just given the measures and not a picture. The legs are the sides that form the right angle. So those two sides that meet to make that right angle there. In other words here, in a right angle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths. Notice how it's written backwards here, and that's okay. We'll talk about that on another page as well. Let me just scroll through. You can pause at any point if you need to write down some things. So I'm just giving you this chance for me to scroll through slowly if you need to pause and record some things for your notes, which you guys have been doing a good job with. Kind of a lot of information on this page, but hopefully it's all very good information for you. Moving on to page 163. I'm sure you're wondering, why is this useful? This is useful for a number of things. The blatant reason that we'll be using it is you can use the Pythagorean theorem to find the length of a side of a right triangle when you only know two of them. You can find the third one, so it's that finding that variable piece. Some people will tell you that they use it in building a lot. If you have Mr. Meyer in 8th grade, he'll let you know about that. Sewing, one of my 8th graders came up with that when you're sewing, maybe if you're quilting, you need different patches. TVs, if you're trying to put a TV in a TV stand, you needs to fit in there, and those are you can find the measures of the diagonal of a stand or a TV. and there are a number of other things. So maybe you could bring some ideas that you have to class as well. So to find a missing side length, you can write an equation and use that to find the missing length. And it says round to the nearest tenth, so we're going to do that. Notice here it says the symbol, like I showed on the other page, is used to determine the right angle. So that tells you where the right angle of the triangle is. Here we're given A and B, and we're looking for C. So this is our equation, and again, this is the backwards version. You can still write it, no problem, with the A first. It's kind of like the situation where it's, 2 plus 1 equals 3. That's still true if I say 3 is equal to 2 plus 1. It's okay that the C is on the other side. So I write down the Pythagorean theorem. This is how your work should look. The formula written, then you replace with the values you've been given. We've been given A, and we've been given B, and what we're trying to find is C. So we replace A and B with 9 and 12. We evaluate, meaning we solve 9 squared and 12 squared for 81 plus 144. C squared stay the same because nothing's changed there. We add those two digits together for 225. And so C squared, so on C times itself, the side length times itself is 225. Then we take the square root of that number. So the square root of 225 and the square root of C squared. Remember, those are the inverse. So if we take the square root, it's like those two things cancel, and we're just left with C. Taking the square root there, then C is equal to 15 or negative 15. The reason that we circled 15 here is because the equation has two solutions, 15 and negative 15, because both of those numbers can multiply by themselves to get to 225. However, it's the length of a side, and that has to be positive. We don't count negative inches, so therefore it's going to be 15 positive inches long for this side. So in that case, we were looking for C when given A and B. Notice here, we're given A, we're not given B, and we're given C. So it still is going to apply where we plug in what we're given and we solve for what we do not know. So in this case, we plug in A, we plug in C. We write down our Pythagorean theorem, and A and C are what we're given. B is what we're looking for. So I plug in my A value of 8, plug in my C value of 24, and I'm going to be looking for B. So I evaluate 8 times 8 is 64. 24 times 24 is 576. This is just like solving this in this case is a two-step equation because of the square. So I have to get my variable alone. To do that, I'm going to subtract 64 from both sides. Like your train tracks are right here for you, my visual learners that are used to that. And some of you maybe want to do this vertically. It's fine. So I subtract 24 from both sides, and I bring down what's left over. And I have B squared, so B times itself is equal to 512. Therefore, I take the square root of that, and 512, and I'm going to round because it doesn't quite turn out nicely. So I'm going to round it, so B is approximately 22 6/10. I can use a calculator. That's okay. And so here's a note. Check my reasonableness. The hypotenuse is always the longest side, we learned. C is always the longest side. And 22 6/10 is less than 24. That's a reasonable answer because it's representing B, and C here should be our longest side. So if we would have ended up with a number bigger than our C value, our C length, we probably would have known something was wrong. So that's how you can check the reasonableness. So there we go with that indication there. All right, so the length is about 22 6/10. What unit were we in? Meters long. Positive, of course, because it's a length. You could pause me right now and try these bottom two. That might be a great idea. And then come back and see if you were correct and kind of work out those things. So I'm going to start by labeling. I was given A and B, and I'm looking for C. So first thing I do is write down my Pythagorean theorem. A squared plus B squared equals C squared. If you were someone who likes doing the C first on this side, that's okay. I like it this way because it's alphabetical order. And so my second step would be to plug in what I'm given. I'm given A, which is 24. I'm given B, which is 18 yards. And I'm looking for C. Next step is to evaluate those squares. So I end up 24 times 24 is 576. 18 times 18 is 324. And that's set equal to C times itself, or C squared. I add these numbers together and I end up with 900 is equal to C squared. And I'm not done here. A lot of people want to stop here, but you can't because you haven't solved for C yet. To undo squaring, I take the square root. Again, excuse the pen. And square root of 900, I know the square root of 9 is 3. And I can use my calculator now at this point, but I can check that this is going to be 30, those 2 zeros on the end. So I get 30 is equal to C. And remember, this squares cancel because you're taking the square root of a square, and those are inverse. So my answer then, the length of side C is 30, and I remember to label 30 yards. You try B here. B, you are given A, you're looking for B, and you're given C. So again, I'm using my Pythagorean theorem. A squared plus B squared is equal to C squared. So I plug in what I know. I know A is 3, so I plug that in. 3 squared plus the length of B squared should be equal to 8 squared, according to the Pythagorean theorem. 3 times 3, or 3 squared, is 9, plus that B squared, which I don't know, is equal to 8 squared, which is 64. Again, notice just because I'm adding 9, I know I see add 9 to do the inverse. I'm going to subtract 9. So I just bring down what I have left over. So I have B squared is equal to 55. I know 55 isn't a perfect square, so I'm going to know that I'm going to end up with a decimal here. But to do that, I take the square root to get B by itself, because a number times itself is squared. And then to find out which number, you take the square root. Square root of 55 is approximately rounded to the tenths place. I can use my calculator, 7 4/10. And this would be labeled in units miles. And again, it's a distance, so I'm not going to take the negative square root. It's going to be the positive. It's a positive distance. Hopefully you got those right. If not, hopefully you can find your mistake and make them better. And hopefully you are being nice about my pen writing. I think I'm doing pretty okay here. All right, last little set here. If you reverse the parts of the Pythagorean theorem, you've formed its converse. The converse of the Pythagorean theorem is also true. So if the sides of a triangle have lengths A, B, and C units, such that C squared equals A squared plus B squared, or reverse those around, that's okay, the triangle is a right triangle. This just means if you're not shown a triangle, you're just given lengths, you can plug them in, and if it's true, meaning if both sides remain equal, then it is a right triangle. So we'll show you that here. So here, we're going to determine if the three sides of a triangle that are 5 inches, 12 inches, and 13 inches, if they make a right triangle. So I write down my formula, my Pythagorean theorem. I plug in what I'm given. I knew 13 was C because it's the longest one. So the longest length you're given, you plug in for C because the hypotenuse should be the longest side. Then I plug in A and B, respectively 5 and 12. I evaluate those numbers, so 13 times 13 is 169, 5 times 5 is 25, 12 times 12 is 144. I add them, and I simplify. I have a check mark here because since both sides remained equal, that means that the Pythagorean theorem for these side lengths was true, and that means that this triangle is a right triangle. So a triangle with the lengths 5, 12, and 13 is a right triangle. So you can try this one. Determine if these side lengths, 4, 7, and 5, are a right triangle. Notice it says draw a picture here to help you with that. And I'm going to in this case because I see that the longest side is in the middle there. And that could throw me off. I could do ABC, but I know that my hypotenuse should be the longest side, so I know 7 is the longest. So that should be C, my right angle here, and my A and my B should be the other sides. So that makes me know that I can plug them in correctly to my formula A squared plus B squared equals C squared. So I can plug those in for 4 squared plus 5 squared is equal to 7 squared. And we're going to find out if this is true, then this is a right triangle with those lengths. If not, if they don't remain equal, then they may form a triangle, but it wouldn't be a triangle with a right angle. 4 times 4 is 16. 5 times 5 is 25. 7 times 7 is 49. Here's the tell. 16 plus 45 is 25 is 41, and that's supposed to be equal to 49. Well, we know that those numbers are not equal, so what that means is that these side lengths do not create a right triangle. That's what we know. The Pythagorean theorem can help us quite a bit. So, rewatch the video or go pause on places you need to. Check examples in the book. Check out Personal Tutor. There's a lot of things out there on Pythagorean theorem. And we will see you next time. Have a great time.